Okay, folks, good evening and welcome to another Tuesday night lecture series with our very own George GI4SJQ, who's going to be delivering a talk on connectors, what to use and when to use them, if my memory serves me right.
Yeah, that's more or less it.
So, George, if you can carry on whenever you are ready.
Okay.
And yeah, over to you.
Okay. Well, introduction for those who don't know me. Dave's already given you my call sign, GI4SJQ. Got licensed back in 79, did the Morse test in 83, got my full call, played around with HF for about 10 years, went very quiet for about 10 years, got interested, got back involved in radio again in the early 2000s, started mixing computers up with it, doing a lot of contesting, playing with VHF, UHF, a wee bit of data modes, favorite mode CW, chasing DX, sometimes successfully, sometimes not. One of the things that I always tried to do was use the best cable I could afford, and sort of never thought about it much up until I got involved with the club and we started doing a bit of training. And well, everything will become evident once we get into the PowerPoint here. So I'll just swap over to the PowerPoint. So everybody should be seeing that okay, I hope. So coaxial cable and connectors, making the right choice. So the reasons for this talk. At the club, we're always being asked the same question by people. Normally somebody's just got their license and they ask this question: what should I use cable-wise? When we're doing foundation and intermediate training, we get asked the same question. So the idea of this talk is to give you some practical steps that you can use to empower you to make that decision, to give you some tools for making that choice, and so that you get the right cable for the right situation. So coax cable, what we need to understand. Well, before we actually look at coax cable, we need to understand about something called the decibel, because our cable has loss. It's not a perfect conductor, and that loss is measured in decibels. So a wee bit of understanding about what the decibel is and where it came from. We'll look at that first. Then we'll look at the effects, what affects your cable choice. So frequency, length, the loss of the cable, and the cost. We'll take a quick look at connectors and have some samples of different connectors to use. And there was going to be a practical, but I couldn't get my software to work with my antenna analyzer on this PC. I have far too many COM ports on the PC, and it was doubling up on them. And other than delete all the COM ports and start from scratch with setting everything up again, so that wee bit's missing. But I do have some practical that I did previously that I'll be able to explain and go through, and you'll see how it sort of ties in with published results. So before we get started, what is the dB, the decibel? The decibel is a relative unit of measure. 1 dB equals 1/10 of a bell. And the decibel measures the relationship between two quantities in the same units. So, for example, watts or milliwatts in cases of amateur radio. It is defined as 10 times the common, brackets base 10, algorithm of the ratio of the measurements, and the formula that we use and we can use in amateur radio, where X is in dB, it equals 10 multiplied by the log of quantity 1 divided by quantity 2. dB can be used to express a change in value. We would use that sometimes in amateur radio. So You could say, well, 3 dB or plus 3 dB or minus 3 dB, referencing something so that we know what we're referencing. So if I put my power output, if I'm running 50 watts and I put my power output up by 3 dB, I'm now running 100 watts. I'm doubling my power. In practice, dB is used all over the place. On receive, your radio's S meter, in theory, should be calibrated in dB. Not all radios are. Each S unit should equate to a change of 6 dB. So if you have a signal that is S5 and the guy turns his antenna and he goes to S6, that should be a change of 6 dB. Not all radios are created equal. Not all radios are calibrated the same. Good old antenna manufacturers use dB to express the gain of an antenna, and you will see it either expressed as dBi or dBd, or sometimes they just call it dB, which is really confusing. dBi, the I stands for anisotropic radiator, which is a theoretical point source. If it's dBd, that's relative to a dipole. We all know what a dipole is. dBi equals dBd plus 2.15. So manufacturers sometimes, they sometimes forget to specify dBi, dBd, but a lot of them use dBi because it looks better. If you've got two element Yagis, each with 3 dB gain, and you specify one with dBi, it becomes about 5.1 dBi against 3 dBd when it's referenced against dipole. So looks better. Big thing to remember, for example, a 3 dB change, either plus or minus, is a change by a factor of 2. 6 dB is a factor of 4. Coax cable, the loss is measured in decibels. And the main thing to remember, if you remember anything about dB, and this makes it easier to work out, 3 dB increase or decrease in value equals the value multiplied by 2 or divided by 2. So if we have 10 watts out and we add 3 dB, we get 20 watts. If we have 10 watts out and we have minus 3 dB, we're down to 5 watts. 6 dB equals the value multiplied by 2 and multiplied by 2 again, or 2 to the power of 2. And the negative value is the same thing. It's divided by 2 to the power of 2. So in that case, 10 watts out, if we had 6 dB, if we had an antenna with 6 dB of gain and we're measuring our ERP, we would have an ERP of 40 watts. If we had 10 watts out going into, say, a dipole, and we had coax cable that had 6 dB loss, we would only have 2.5 watts getting to the cable. 9 dB, similar fashion, it's the value multiplied by 2, multiplied by 2, multiplied by 2, or the value multiplied by 2 to the power of 3. So 10 watts out from a radio going into an amplifier with 9 dB gain would give you 80 watts out. If you had 10 watts out going into some coax cable and you had 9 dB of loss, you'd have 2 watts at the other end. 10 dB, 20 dB, 30 dB, 40 dB are all nice ones, because 10 dB is 10 times increase or 1/10 if it's a minus. 20 dB is 20 times or 1/20th, etc. So, if you remember anything about dB, those will help you work out in your head very quickly where you are. So, coax cable frequency and length. The loss is specified in decibels, and it's either specified per 100 meters or per 100 feet. Very easy to get caught out. I know when I was putting this together, a couple of times I had to do a double take of the specifications, because a lot of them specify per 100 feet, which is 30.8 meters roughly. So you specify it in feet, it looks a lot better than in 100 meters. Mentioned earlier on that coax cable is not a perfect conductor. It has loss, and that loss increases with the length of the cable and as the frequency increases. So for example, if we had a chosen cable that had a specified loss of 10 dB per 100 meters at 144 megahertz, and we needed a 50 meter length, we would have 5 dB of loss in that cable. If we had a 25 meter length, it would be 2.5 dB of loss. If we had a 12.5 meter length of cable, it would be 1.25 dB of loss in that cable. If you use the cable at a different frequency, the cable loss will be different, and that's where you can look all that up. So how to find this information? Well, back when I was licensed, we had the ARRL handbook and the RSGB manual, and there was another RSGB book which was very good, and it had tables, lots of tables, and you could look up all the different cable types, the frequency, and the loss. We have an example up in the top right-hand corner of this: coax cable loss or attenuation in dB per 100 feet. And it gives you the common coax cables, common frequencies, and how much loss is in that cable. At the bottom, it specifies whether it's 50 ohm or 75 ohm. For amateur radio, we use 50 ohm. We don't use 75 ohm normally. The internet is a great resource. There are tons of info out there, and some websites have calculators. The picture in the bottom right-hand corner was taken from W.H. Westlake's website. You can enter your length of cable in there and in meters, and it will tell you how much loss you have for that length at 2 meters, 70 SEMS, 960 megahertz, 23 SEMS, 2 gigs, 2.4 gigs. So very, very useful wee table. Another good one is KV5R. He has a very nice calculator that will do all sorts of things. The big thing to watch out is that what it's specifying that loss in. Is it per 100 feet or is it per 100 meters? Because that can catch you out. So example, you need a 15-meter run of cable to connect a rig to the antenna. So the first questions you need to ask yourself is, what's the highest frequency I'm going to use? Is it HF? Is it 2 meters? Is it 70 SEMS, 23 SEMS? Or maybe you're trying to get onto QO100. Is it 2.4 gigahertz? Second question is, how much do you want to spend? Because you can spend a lot of money on cables, especially when you get into the specialized stuff. Once you've asked those questions, next thing is to go look up your cable specifications. Look up the loss specified in dB per 100 meters or dB per 100 feet. This example, I'm using meters. So chosen cable is 13 dB of loss per 100 meters at 2 meters. We need 15 meters of cable. So it is the loss in dB per 100 meters multiplied by the cable length divided by 100. And that will give you the loss in dB for the specified cable length. So there's the wee formula. 13 dB multiplied by 15 meters divided by 100 equals 1.95 dB at 2 meters. So we now know what our length of cable is and what loss we have, 1.95. What does that mean for the radio for putting power in and getting power out? If you put approximately 50 watts in, you'll have about 32 watts out at the antenna. So it's less than 50% loss. One thing to note is loss is not just on transmit, it's on receive as well. You will have 1.95 dB of loss on receive and on transmit. For some people, that's important, or more important if they do weak signal work. But for 15 meters of cable at 2 meters, almost 2 dB of loss, it's not too bad. So how does frequency affect your choice? Frequency is an important consideration because attenuation loss goes up as the frequency increases. Always calculate your loss at the highest operational frequency. So if you're putting up something like a Diamond X50 or an X510 or whatever for 2 meters and you plan to use 70 sems, consider 70 sems, because a cable that might be acceptable at 2 meters might have a lot of loss at 70 sems. The chart opposite I pulled off the internet, and it shows RG174, which is the really thin coax that you'd use maybe for some of the mag mount antennas. The wee small ones use that, or you might use for a wee patch cable. You can see that the loss, and that is loss per meter. At 200 megahertz, it has 0.4 of a dB per meter, and up at nearly 23 sems, up at 1000 megahertz, it is over 1 dB per meter. So if you had 3 meters of it, you're going to lose 50% of your signal in that cable. And as you can see, as you go up through the better cables, RG58, RG8X, and then some of the other cables, the 9914 and the 9913, the loss per meter significantly improves. So one of the things we need to do is compare the loss with the cost, and everything comes at a cost. Some of these cables can be very expensive. It depends on how expensive it is to you. For VHF, UHF with long cable runs, you really want to try and buy the best you can. If you're using very long cable runs, you might want to consider a masthead preamplifier on receive, and you might want to increase your power output of the radio on transmit. And on the right hand side there, we've got a little table which is showing different cable types and their loss for a 20 meter length at 435 megahertz. So RG213 is the very first one there. It has 16.9 dB of loss per 100 meters. If we were using a 20 meter length, we're going to lose 3.2 dB. So if you're putting 20 watts into it, you're going to get just less than 10 watts out. You get into some of the MUARC cables and the EcoFlex cables, you're getting a bit more power. You're not getting massive increases in performance there. I think the best is probably about 25% loss out of all those, but it also breaks down the price. So LMR 400, which is a popular cable, you're going from £1.50 for a meter for RG213 up to £5.50 a meter for LMR 400 to get an extra 4 watts at the far end. So it's based on your cost and your how much you're prepared to pay. Westflex comes in there as well, and the EcoFlex and the Ultraflexes that the likes of Martin Lynch and Nevada sell are in there as well. So, example, if somebody is interested in weak signal work, what can they do? Say you want to work EME, Earth, Moon bounce, on 70 sems, and you have a 25 meter run of cable, and you're going to use Ultraflex 10 at 70 sem, connecting to your 70 sems Yagi. So the first thing you probably will want to do is fit a masthead preamp on receive, because you're interested in really weak signals, so you don't want too much loss. You might want to run full legal limit under your license, and if you have a full license, that's 400 watts. The cable loss for 25 meters of Ultraflex 10 is 2.15 dB. So if you have 400 watts in the shack, you're going to get about 243 watts at the antenna. If you want to have your full legal limit at the antenna, you need an amplifier in the shack delivering about 650 watts RF output. Or you could move the 400 watt amplifier up to the masthead, but that mightn't be so easy to do. The one thing to remember is our license specifies the output power is measured at the antenna. So there's no problem running 650 watts in the shack if you know you're only getting 400 watts at the antenna. So from cable, we'll move on to connectors, because connectors can be as important as the cable. No point buying very high quality cable and putting nasty cheap connectors on it. The PL259 dates back to the 1930s, believe it or not. The standard PL259 is not a waterproof connector. You need to make sure it's well insulated with self-amalgamating tape and insulating tape to keep the water out of it. It was named, and it's known as a UHF connector, but it was named when UHF meant frequencies above 30 megahertz. And we now know that UHF is frequencies above about 300 megahertz. So it's sort of, its name does not mean you can use it at 70 SEM successfully. It's a good connector at HF, and it's good up to 100 megs, but personally I would consider it a poor choice above 144 megahertz. I try not to use it at above 144 megahertz. It's not a 50 ohm impedance connector. Your cable is all 50 ohms impedance. Your radio is designed to have an impedance of 50 ohms. Your antenna is designed to have an impedance of 50 ohms. And a PL259 is not 50 ohms. The reason why it's not a good idea to use it above 2 meters is the size of the connector in relation to a wavelength is getting larger as you move higher in frequency, and therefore it basically puts a bump into your nice 50 ohm line from the radio up to the antenna, and can cause you a few wee problems. There's lots of cheap ones when you go to the rallies. I've even seen fake gold-plated ones, and they probably work fine at HF. I've always tried to stick with good connectors. I've got a couple of examples here that I can show you. And if you're looking for good connectors, Amphenol make a good PL259. What you want to look for is silver plating and preferably Teflon insulation. The Teflon insulation will not melt, and the silver plating is easier to solder to. Also, compression types are very good, and they are intrinsically waterproof if you put them together correctly. There are also crimp-on connectors, and I would use crimp-ons. I'd use all three types, but I like crimp-ons. They're standard in the industry, and a lot of contest stations are now swapping over to using crimp-ons because they're more reliable. So PL259s, we've got a couple of PL259s here. Just get them centered. They look very similar. This one here is an Amphenol. This is just a cheap and nasty. You can see when I turn them that way, this has got some sort of brown material. Some of them actually use plastic in them. The Amphenols should be Teflon centers in them. And if you want to see what a compression type looks like, this is a compression type. So we have traditional looking plug, normal looking plug at that end. The pin's fixed, and you solder the center of the coax to the pin, and that one's been gold plated. And then on the other side, we have a nut which slides over the coax. We've got a compression ring. We've got quite a thick washer, and we've got a washer. And if you're fitting the coax, and this plug is not designed for this cable, but this ring will actually fit and butt up tight against the braid, and you can splay the braid out. So when you compress it, the way you would fit it normally would be the ring at the back, washer in the middle, and then the wee front bit, whatever it's called. And when you tighten it up, it compresses the braid and makes a good solid joint. Normally you use a couple of spanners to tighten that up. Makes a good solid job, so it does. So that's PL259s. Crimp on is very similar. You just need the crimp tools to put them on. Once you've got the tools, they're easy to fit. And if you make up lots of cables, then very handy to have the crimp ons, because it's quick and simple to put them together, and they're pretty reliable. Although I would always check them with a multimeter just to make sure you don't have a short. N types and BNCs. The N connector was invented in the 1940s. It is a fixed impedance, and it has a high power rating and is available in 50 and 75 ohm plugs and sockets. Make sure you don't buy the 75 ohm connectors, because the 75 ohm connector has a different pin diameter. They will physically fit. You can put a 75 into a 50. You won't do the 50 ohm socket because the pin size is different. Typical, just getting some samples to show you here of N types. I've got a couple of them here if they all fit in the picture. So yeah, watch out for 75 ohms. If you see cheap N plugs or BNCs, make sure they're 50 ohm before you buy them. They're good to at least 11 gigahertz, so they work right up well into microwaves. They're the connector of choice for UHF and microwaves, and they're available in a compression or a crimp-on. I've used both. Both work very well. BNC is a very similar type of connector, available either in a compression or a crimp-on. It's a lower power connector than the N type. It's excellent at VHF, UHF, and the low microwave frequencies. And we got a couple of N types here. We got a crimp-on one. Got a crimp-on one just here. And then we've got a compression type, which is very similar to the compression type that you get for the PL259. And as I say, if you've got a couple of spanners to get them nice and tight, they make a really good job. They are waterproof, but I would always seal them with self-amalgamating tape and a layer of insulating tape over the top. Self-amalgamating tape's great stuff. I've never had a leak using it, but I've always covered it with insulating tape because it's not UV stable. And if you leave self-amalgamating tape out in sunlight, it'll break down eventually. So always cover it with insulating tape. If we look at a BNC, that's a crimp-on BNC. It's very similar in construction. That one's for air cell 7, I think it is. So it's a wee bit bigger and a wee bit beefier than normal BNCs. So how to prove your cable is good? Well, sometimes you turn up at rallies and people are selling coax cable, and it might look like a very good offer. I certainly have been able to get some good coax at rallies. How do you prove it? But how do you prove that that cable that you have bought from a supplier actually is what it's meant to be? And the way to do that is you can measure it. Number of ways of doing it. You can measure it using tools that you have in the shack. So if you have a known good dummy load that is good at the frequency you want to measure, and you've got a watt meter, it doesn't have to be a bird. It doesn't have to be a really expensive watt meter, as long as it's a good, reliable watt meter, not like the wee cheapy SWR bridges that we used to buy when I got licensed first. That were well, they told you what the SWR was, but trying to work out what the power output was another matter. You can use an antenna analyzers. Many devices like the the nano VNAs that have come out will measure cable loss. They work very well when you connect them to the software, because you can then specify the type of cable you've got under test, and they will measure the loss of a piece of cable. The only thing to remember is when they give you that value, and if you, yeah, my mouse does work here. If you look here, this is actually showing cable loss. This mag log, or log mag, minus 11.93 dB that you can see. The one thing to remember about that is measuring the loss from the analyzer to the far end of the cable and back again. So you need to divide that value by 2 to get the actual loss of the cable. Or if you really want to, you can get yourself a spectrum analyzer with a tracking generator built in, and you can use that to measure cable loss. Something you might or might not have access to. Most people don't have access, but something like a nano VNA, that's the new version, the nano VNAF that I showed there, or even the original one, will do cable loss. And some of the tests that I have done have shown that it's actually pretty accurate, matches quite well what against the reported figures for coax cable. The method that I'm going to show you also works very well, and it uses a watt meter, a piece amateur radio, equipment, a transceiver, and a dummy load and a few adapters. So using a watt meter and dummy load, you need a radio covering the frequency you wish to measure, a known good watt meter. Most meters are accurate between 5 and 10%. Even a Bird 43 that you'll pay hundreds of pounds for is only good to plus minus 5%. But we're not interested in the last half a watt here. We're interested in ratios, and so as long as it's got a big enough display on it that you can read the power meter and it's repeatable, then it's good enough. You'll need a short patch cable to connect the radio to the radio. You might need some back-to-back connectors, and you need a known good dummy load. Lots of dummy loads out there that are good on HF, but are not a lot of good on 2 meters and 70 sems. If you're trying to measure, say, at 70 sems, which is what I did, then you want a dummy load you know is flat at 70 sems. So you'll want something that's a wee bit better quality. Doesn't have to be high wattage, just needs to be flat SWR on 70. The simplest way to do that is plug it into the meter and connect the radio and transmit. And if you've got a flat SWR with it directly into the meter, then it's good to go. So here's the method. So first of all, we set up our test radio and we connect a patch cable from the test radio to the meter. We then connect the cable under test to the output of the meter, and we might need to use an adapter to connect to the dummy load at the far end. And we measure the power reading on the meter on transmit. I used an FTM 100. I think my maximum power output was about 46 watts. So radio at the highest frequency that you want to test under. So that's your first reading. So you note down that would be the power into the cable. You then swap the position of the meter. So you might have to take your adapter and put it between your patch cable and your cable under test. Put your meter at the far end with a dummy load connected into it, and you redo the test, and you note down the power output from the radio at the far end of the cable. Take a note of that. You then use this little formula, which will calculate your loss. So the loss in dB of the length of cable under test is 10 multiplied by the log of the power output divided by the power input. And what you will get is a negative dB, a negative value, which will be the loss in dB of that cable. You then just need to convert that to dB per 100 meters or dB per 100 feet to be able to compare it against commercial specifications. So I have a number of different cables. In order that I measured them, I have about RG58, and I've got about 7.5 meters of that with a PL259 and a BNC on the end of it. That was the first cable I measured. This was sort of my reference cable. This is 20 meters of Nevada's RG8 Super XX. Now, I couldn't find a specification for Super XX, so I'm calling it RG8X. But of course, Super XX makes it sound better. But that's 20 meters of it with PL259s at either end. And they're reasonable looking PL259s. This talk sort of, from a personal view, came out of this lump of cable. This is 20 meters of what I thought was RG213. And when I did my tests initially, I discovered that it wasn't very good. And then I realized this afternoon when I measured the length of it why it wasn't very good, because I thought it was 16 meters long and it's actually 20 meters long. So it is RG213, I've discovered. Finally, the other two cables I measured, this stuff here is Heliax, and this is about 12 meters of Andrews, where's the number on it? Andrews FSJ1-50A Heliax. And finally, this is another length of Heliax, which is about 12 meters long. And this is 3/8 inch Heliax. The other Heliax, the Andrews, is 1/4 inch. This is 3/8. And this is about 12 meters long as well. So I went through this process with all of those cables, measured the power into the cable, measured the power out of the cable, and then calculated the loss in that piece of cable, converted it to loss per 100 meters, and then went and looked up the cable where I could to get the specification. So here's the practical measurements that I made. Showing the radio, I used the SAFTM 100D, measured it on 433-425, 70 SEMS. Used a Bird 43 watt meter that I have with a 50 watt slug, covering the 200 to 500 megahertz range, and I used a Bird 50 watt dummy load with end connectors. Some of these things have PL259s, try to use decent adapters to convert them to N types where I had to. So the first one you'll see, RG58, 7.5 meters. I had 35 watts in and 19 watts out. The attenuation for the length measured was 2.65 dB, which works out, when we convert it up to per 100 meters, at 35.38 dB per 100 meters. If I compare that to the online specifications for 100 meters of RG213 up around 70 SEMS, they're quoting about 33 dB loss. That's pretty close. That's within 2 dB of specification. Bearing in mind that I've got a couple of different connectors. I've had to put adapters in there. You know, that's not bad. The Nevada RG8X, again, it's a 20 meter length of cable, 46 watts in, 14 watts out. The length of cable, I had 5.17 dB of loss. That worked out at 25.83 dB per 100 meters. And I looked up RG8X and it comes in at 25.5 dB per 100 meters on the internet. So again, that's proving that this practical way of measuring a length of cable is working, because we're getting results very similar to what we have on the internet as published specifications. The cable that I thought was really poor, the RG213, It's a couple of dB out compared to the published spec, but then that cable could have been sitting around for 20 or 30 years, might have a wee bit of damp in it. It's a length of cable that I was given. So it's not bad, it's pretty close. It's a lot better than it was when I did this last week. And that's down to the fact that I thought it was 16 meters and not 20 meters. The Andrews Heliax I measured this evening, again, just to make sure. And 44 watts in, 31 watts out. For that length of cable, which is approximately 12 meters, I've got about 1.5 dB of loss. For 100 meters, 12.6 dB comes in pretty close to the specification for Andrews. The 3/8 Heliax, again, it's better again because it's a larger diameter Heliax. I don't know the type of that cable, so I can't go and look up the specification, but I'd be pretty confident that it's a pretty good piece of cable. So, some final thoughts to consider. All of the above are based on a resistive 50 ohm load, not connecting it to a real antenna. When you connect to a real antenna, you need to consider your VSWR on that cable. It will have an effect. Your RF power output. Cables with high losses will mask bad SWR. So if you use a cable with a lot of loss, you won't see it at the station because you're losing it in the cable. You're losing that high SWR in the cable. So it might look good at the shack, but it mightn't be good at the antenna. The other thing to watch out for is high power and bad SWR. That will cause a lot of heating in coax cable, especially if you're using something like RG58, say at HF, which would be a popular place to use RG58 because the loss is quite low. If you've got high power, you got bad SWR, you're going to have a lot of heating on coax cable. If you search the internet, you will find stories of people burning up cable, melting cable, because they run too much power into bad SWR. So that's it. We'll open it up to questions, and if I can answer them, I'll do my best.
You're happy enough to answer a few questions then,
Yeah,
George?
yeah. If I know the answer, yeah, it'd be great.
Okay. If anyone has any questions, you should be able to unmute yourself in 1 second.
The one thing that I did find was that actually measuring it practically with a watt meter and a dummy load worked out pretty darn close to what I was getting from the published results, which gives me a bit of confidence that if I got a piece of cable and I wasn't sure about it, I could use that method, and anybody could use that method to check it. And as I say, there are times when you go to rallies. I've been down at the Loch Earn rally a few times when some of the guys from EI will come up and they'll have a table full of very nice looking coax that's been stripped off a mast somewhere. And you've got the equipment probably sitting at home to be able to measure it and prove how good or how bad it is.
Okay, well, if anyone has any questions, feel free.
Heliax cable looks very good, George. Do you know where Mom would get some of it?
It's fitting the connectors on it's the problem.
My brother used to sell it. He worked for Andrews Antennas for about 10 years, and you can get it from Andrew Antennas, but it's frightfully expensive.
Yeah, well, I have a length of that Andrews with no connectors on the end of it, and it's actually a good run. And I bought a couple of connectors at about £6 each off an M0 on eBay. And then I went to look at fitting them, and different matter altogether fitting those things. Need a special tool to prepare them, and because they're a solid copper jacket around the outside of them. There's no braid.
Yeah. Also, there's a very, very wide radius of bending. You're not allowed to bend it like you can the other coaxes.
Yeah, to keep the losses down, they tend to use foam dielectric, which reduces loss. But yes, if you kink it, it's scrap.
Mm-hmm. Yeah.
Sean, I see there you've tried to break in a few times. Go ahead, Sean.
Yeah, I just want to commend everyone. I'm a new kid on the block here, and I've been trying to join the Zoom conferences on a regular basis. And my good friend George, I promised I wouldn't let him down. So I want to first of all commend him. I was really impressed. I use Zoom with work, and I was thinking, my goodness, George has put us all to shame. And I work for the government. I'm thinking, I've trouble keeping one screen going, but George was bringing different things and bringing in the exhibits and whatever. So well done, George, and I really enjoyed it. I'm just going to share that my colleague there on GI1 that was saying that his brother worked for Andrews. I had reason to work at a lot of high-powered stuff. It was 5 kilowatts at FM, and we used LDF 450. And I have to say, you do not want to put on those connectors. The connectors were £50 each, and the shell bearings that went around them. So whilst it's attractive for the cable loss that George has worked out, sometimes it's really not worth it, because you can actually break the connector if the connector is on top of the antenna, and you've had to have a wide loop because you can't really you can't have it too tight. Sometimes it's not worth the effort for the loss. Yes, when you have to do it at microwave, etc. But I've experienced it in the LDF 450, and the LDF 450 is, George, you can tell me what a 450 is. Would that be 7/8? I think that's what they call it.
Yeah, if you look on YouTube at some of the videos, you'll see that they use an electric drill to fit with a tool on it to actually cut the cable and prepare it to put the connector on. So any coax that needs an electric drill to prepare it is a bit too big for me to use.
Well, the reason why we used it, it was 5 kilowatts going up the LDF 450 into 16 phased antenna into a balanced splitter, and every one of them was an LDF 450 connector. So I didn't like working at them. Some of them were 100 feet up, so they would have had to take the harness down to do it. So I was just sharing that experience, and I was fascinated with the losses. I wasn't even aware of that level of losses even on the RG213 from your test. So I'm going to shut up for now, but it was more to commend George and say I'm glad to be there, and to see Herbie Graham. Welcome Herbie there from County Fermanagh. We'll have to chat some of these days. So I'll bow out and just mute the microphone, but I'm here anyway.
Hi George, it's Andrew MI7ELJ. Thanks for a really informative talk. I got a lot out of it. I just had a question about the Nano VNA, which I got one of those. They're great. They're very tricky to use, but I kind of was able to figure out, the resonance points on the antenna. But do you need a dummy load when you're to measure the cable loss? And does it work with the antenna connected to the other end of the coax?
Yeah, if you're using an antenna analyzer to measure cable loss, you actually measure it either with a short at the far end or at open circuit at the far end. So what you're using is that wee device there. I've printed a wee case for mine, but it's
a 3D printed case. Yeah,
it's a tiny wee thing. It comes with if I can get them out. It comes normally with 3 wee SMA connectors. One of them is an open circuit, one of them is a short circuit, and one of them is a dummy load. And the important thing that I discovered when I was working with them was before you do any measurements is to run a calibration process on the Nano VNA or any of the analyzers that allow you to do the calibration. It works a lot easier if you run it through the software on the PC, and you can run the calibrations, and you can do all your normal measurements. The advantage of having it connected to the PC is you don't have to write your measurements down. You've got it on the screen. You can save it off as a file, or you can screen dump it and save it off somewhere into a document, and then you've got it for reference the next time you do it. You can look it up. It would have been something I would have done traditionally on, say, the HF antennas. I would have done an SWR scan of an LP100 watt meter for HF, and it's connected to the computer. And the guy in the States that designed it produced a little piece of software that would talk to the radio, talk to the watt meter, and it would step the radio across a particular band and do an SWR check every 10 kilohertz, whatever you decided, and it would produce a nice little graph. You could then save it, and in a year's time you could go back and recheck your SWR across the band, see if your antenna had changed resonance. You can do the same thing with an OVNA. You can plug it into the computer and do it. Great wee tool, but always calibrate them.
I've just bought one of those, but I'm envious of your case. Where did you get that?
Thingiverse, 3D printed.
Ah, right, okay. Have you got
you need access to a 3D printer to be able to print it, but
right, that's something I haven't got yet. Yeah. Yeah, okay.
There's something to add to the list, Liz.
Yeah, I've got an XYL here who's getting very curious about the little boxes that are arriving.
Yeah. Yeah, I've had far too many little boxes arriving over lockdown.
I have a question about the mass of the cable. Okay, so we've talked about the losses and the costs.
Yeah.
But actually, in a practical installation of a dipole, of course, you've got three points of reference. You've got two ends of the antenna, which are bits of string and insulators.
Yeah.
You're going to fly those somewhere high. And then in the middle, you've got some kind of connector, and then a coax coming down. And the weight of that coax is actually quite critical to the success of the dipole. So the ideal would be to get a very low mass cable length of, say, 10 meters to fly without too much center point weight on the construction, and then to have 100 meters of fat cable if that's what you need to get across the garden. Now, are the dB losses additive between the light cable and the heavy cable, or does the SWR start to do funny things? Does the RF start to do funny things on the joint of two different cables?
Yeah, I think you're talking about something that I'd actually been thinking about. For myself, I have a 40-meter dipole. So I have 66 foot of wire with a ballon in the center.
Yep.
It's strung between the mast in the back garden and a tree out in the field. So the ballon is sitting floating there in the middle with no support.
Yeah.
And there's a length of RG58 that runs from it directly into the shack. And it probably is maybe 25, 30 meters of cable or more. And I'd thought to myself, well, I could run RG213 as close to it as I possibly could, and then I could join it into the RG58 for the run up to the ballon. So I have the lightest coax available going up to the ballon. It's all 50 ohm coax. So you'll have the attenuation of your length of RG58 plus the attenuation of your length of RG213 or whatever else you're using. But realistically, if you're using a dipole on 40 meters, you mightn't have too much loss to start with. It's down to working out your cable length and the loss in the cable. at that frequency. So it'd be a case of looking up, say you had 20 meters of cable from the shack up to your 40-meter dipole, and you want to use RG58. Go and look up the loss at 7 megahertz, or as close to 7 megahertz as you can find, and then calculate it out for 20 meters, and it'll tell you how much you're going to lose in that cable.
Or if you were going to join two cables like that, well, I know if I was going to join two cables like that, I would consider the loss at the joint too.
Yeah.
So my intention would be I would use a female connector in one length of cable and the male connector in the other, rather than two males in a straight through.
Yep, that's the idea.
It probably wouldn't make a hell of a difference, but I would try and cut down as many joints as possible.
Yeah. Two PL259s into a back-to-back SO239s, not as good as a proper SO239 line socket on a PL259 going into it, or the N equivalent of it. But at HF, loss is going to be negligible. I would think anyway. But yeah, Les, I've been thinking the same thing about, well, my reasoning is the houses around here have flat roofs, and I've got a length of RG58 lying on the roof. And when the wind comes, the tree moves, the antenna moves, the cable jumps up and down, hits the roof, wakes me up in the middle of the night. And I thought RG213 would be a bit heavier and wouldn't move as much.
Yeah. Or you could use a brick.
Yeah.
I just see there, George, Herbie has put a wee message in the chat there that he's modified a PL259 to fit the 3.8, and it works okay.
Very good.
Yeah.
That's good. Yeah, I've done things like that before. When I bought a length of Westflex 103. I think it's 103 Westflex. It has a slightly different pin diameter, center conductor diameter. So standard N types PL259s don't fit it. And I've been known to put a bit of solder onto the center conductor to make it a solid piece, and then get a file at it and file it down to make it fit the pin on a standard N type or whatever.
You didn't mention SMA connectors a lot.
SMA, well, if you look at SMA's been used by amateur radio for quite a while now on handhelds, but it's actually a connector that's designed for UHF and microwaves, which is designed not to be taken on and off the way we use them. In fact, with SMAs, if you take a look, you can get a torque wrench that is designed to torque them on properly to the right tension. I don't think we'd be too keen on doing that to our handhelds. We might take the socket off when we try to undo it. But they're a handy wee connector, but most part I try to stick with BNC's N types and PL259s at HF.
George, you were mentioning about N-type and BNCs. You said the difference between an N-type would be used for high power, BNCs for low power. What's the difference between high and low in wattage? 100 watts, 50 watts? What?
Never actually looked to see what the difference. BNCs are good to maybe a couple of 100 watts. I'd need to look to see what the specification is for them. N-types are just a much bigger, beefier connector, and you get a much better connection when you tighten them up. If you look at the connectors that, where is it? If you look at the connectors that Martin Lynch sell for their cable, you can see here that there's flats on the side.
Yeah.
When you fit that, you can put a wrench on it and you can torque that up tight. Get a really good connection. If you take a look at some of the videos that K3LR has done about PL259s used in his contest station, he uses a wrench, one of the clamping wrenches, pipe wrench, I think maybe it's called, to actually tighten the PL259s onto the back of the equipment. Okay, he's in a setup that's running maybe 1.5 kilowatts from all the amplifiers, so he needs those connectors good and tight. But they're not hand tightened; they're proper cinched up tight. But these M&P connectors, there's flats on them for I think it's maybe a 19 mil spanner to tighten them up.
Cool.
I think it's 16.
Is it?
George, yeah, because I had to go and buy a couple the other week to get a perfect fit. I don't know if you have a gauge there, but I think it's 16. It's not a common size of spanner, I know. It might be 19, but I know.
No, you're right, actually. I've just
16 mil.
I'm just taking a look here. Don't know if that's in focus or not. That's 19 mil across the flats.
Right, okay. Well, 19 must
on that
be.
one.
Oh, is that for a.
Yeah, that's the
10?
end type. That's EcoFlex 10 or.
All right, I use the 7, so it's I think it's 16 for the 7 mil.
Yeah. They're a slightly slimmer connector. Really nice connectors, extremely well made. What I tend to do is I've bought it a couple of times. I've bought EcoFlex 10 and the 7 as well, and I'll buy the cable from Martin Lynch, but I'll buy the connectors from Nevada. The SSB connectors, they're the same fitting, but you get 2 for the price of 1.
Would they be as good a quality?
Well, that's the PL259 one there. I can show you an end type if I can find my box.
No, well, I would take it if you're buying them and using them. They must be all right, George.
Just looking to see if I've got any end types. Yeah, there's an end type there for the Aircell 7.
That's good to know, George, because I spent a small fortune on connectors. They're about £7 a piece.
Yeah.
Well, as George said earlier in the video, there's no point using good quality cable and putting a 50p connector on it.
Yep. I would watch amateurlogic.tv from the States, and those guys have a bit of a laugh every time they go to the Dayton Hamvention. They look out for the fake gold or faux gold PL259s, and they've even given them away as prizes in the past. A bit of a booby prize. But yeah, that's the SSB electronics version of the connector, and it's not a bad wee connector. So it's not. Quite happy with.
And they sell them for Aircell 7 and Aircell 10, which is the same size as the M&P.
Cable, yeah. Yeah, fits perfectly.
There's one type of connector which I found useful recently, and that has I had to get an old one from a rally, and that was an earthed connector. So it enabled me to drop the braid down to earth, and that's helped me a lot.
Yeah, it's like a clamp that clamps around the outer of the cable, and then you can take that to earth.
Yeah, well, actually, this was there's a straight through. I could almost go and get it, but there's a straight through portion, and then there's the outer which connects the screen, and then the outer has a bolt attached to it that you can bolt on your earth.
Okay. I've seen a type, and Sean may have seen them before, with the LMR 400, which is you cut back a bit of the outer insulation and you clamp it onto the shield, and it's for lightning protection.
Yeah.
But it's not a connector as such. It's a clamp that clamps around the outside of the cable. Yeah, that's.
Yeah, that's the one. Yeah, that's it.
Yeah, that's just a converter for lightning, but that's what you mean, isn't it?
That's exactly, Jeff. Yeah.
Yeah. Yeah, there's various types you can get of those. There's Alpha Delta in the States make one with a gas discharge tube in it. I had an issue here a few years ago. It was actually the Saturday after CQ Worldwide SSB, and there was a real heavy rain came on, almost like a hailstorm, but very heavy rain. A lot of static. The HF rig sitting on. I was just monitoring HF, and the static level started to rise. And switched the radio off. Never thought anything more about it. Switched the radio on later on that night. Thought, gee, the bands are dead the night. Checked all the bands. Everything was dead. The static level had risen to the point where it had taken a diode out in the HF rig. So luckily, my HF rig is plug-in boards, and it was a known fault that the manufacturer had fixed in a previous version. But it was literally too much static electricity getting to the diode had blown it. Of course, they're surface mount devices, so not easy fixed, so I had to send the board back. But out of that, I got one of the big electrical boxes you get for feeding mains into a house that you can take the front off. And I sourced a bus bar out of Florida that a company was selling, which had 3 of the Alpha Delta lightning suppressors on it. So this thing's like 1/4 of an inch thick copper. Fitted that inside it, so the coax cables come up into that, and that goes via a very, very thick cable down to 3 earth rods within about 1.5 meters of the point where it comes into the shack. And haven't had static problems since. Heard it go off a couple of times, mostly on 12 meters because the SWR is a wee bit high on 12, and I've exceeded the 170 odd volts of RF that takes to trigger it. But yeah, they're useful wee devices, those.
George, what was the cable we got at the Iron Rally? It was quite good. Was that one of the ones that you were testing there? And it had the connectors that were almost adapters at the end.
That's it there. Andrew's 50 or 1-50.
Yeah. That was
with
quite
N-type
good
connectors.
value.
Sorry, Sean?
And the connectors, it was good value. I think we bought a few lengths of them, but not that long, but they're not heavy. I didn't find them too heavy. 12
meters long. I have one length used on the X300s directly above me on a 25-foot pole, and there's enough cable to get it from there into the shack, and then have a short length of patch cable getting it to the radio.
What I liked about the connectors that were pre-made on it, am I right in saying that they're almost adapters? So as you don't have to drill a very wide hole to get them through. There's some way of taking them off.
Yeah, you can, because of the way they're put together. You can unscrew it and feed it through a smaller hole and put the connector back on.
I think they were good value. I can't remember the guy that was selling them. Could be even on this group, but they were good value. Did we pay a 5 or a 10 or a length?
Paul, MI1AAB, I think, was it, George? I have some of it.
I think they were £10 a length.
I think you got some of it out of my back garden too, George, did you not?
Yes.
Still have some here.
It's very nice cable. Unless you want to buy a length a length of that stuff, which is EcoFlex 10 £3 a meter or whatever. You know, that Andrew stuff is very good. And the 3/8 is even better.
Okay, folks. Obviously, we're recording this part, but just for anyone that's of interest, not that I'm telling people to rush off. We'll continue on with the questions in a minute. But this Sunday, the 14th, is our Mid-Ulster normal sort of formal meeting. And Alistair, who's in with us this evening, is going to be getting, well, I wouldn't say interviews are too much of a formal word, maybe a chat on what life is like as an air traffic controller. And it
Oh
kicks
my
off
God.
at 3 p.m. This Sunday. So the link for that will be up on the Mid-Ulster Facebook group, as well as I'll put it into the GIOTA Facebook group as well. So good evening, Alistair there. I don't know if you want to wave your hand or say hello or anything. Oh, you're still on mute there, but
Sorry.
can you hear us now, Alistair? Okay, well, Alistair will be with us this Sunday at 3 o'clock. With regards to the actual lecture series, next week on the 16th, we have Bobby Waddy, MI0RYL, who is the RSGB Awards Manager, and she'll be talking to us about that. On the 23rd of June, we have the RSGB OAS. What is it and what does it do, with Ian, GI0AZB. And then if he's still there on the very last Tuesday in June, Amateur Radio and Raspberry Pi with Nathan, MI0NPR. So that sort of brings us up until the end of June. And we have a few in the progress there already for July. We will be continuing these throughout the end, throughout every Tuesday in July. So it will be, hopefully, we'll get those filled up and everything else. If anyone would like to volunteer to speak, you're more than welcome on a particular topic of your choosing. But yeah, so thanks so much for joining us tonight. And you're obviously more than welcome this Sunday and every other Tuesday for the links.